Welcome back to the IoT with .NET series. In this video, we're going to learn about what exactly is IoT and the terms that you will come across when reading documentation or talking about the IoT space. So what exactly is IoT? IoT, or the Internet of Things, can be defined as a network of physical objects or things which have embedded electronics, network, and sensors that receive and collect data. The goal of IoT basically is to extend internet connectivity from traditional devices like computers, mobile phones, and tablets to more interesting devices like your coffee machine. Basically, the idea of IoT is it can make everything smart. Now, we can talk about an IoT system in three main parts. So you have your sensors or devices, connectivity, and apps and services. Now, sensors and devices are the electronic components that sit in your IoT device, which receive and collect the data. This data that we're talking about can be something as simple as temperature readings or humidity readings to something a little more complicated like video feed from a camera. The next part is connectivity. Now, connectivity basically means these devices that are collecting all this data are most probably uploading the collected data to a cloud service, which is getting processed and then receiving some data back from these services. In these videos, the Raspberry Pi that we're going to be using can be connected to the network either via an Ethernet port or you can connect it to your Wi-Fi. The last part of our IoT system is the apps and services itself. Now, the point of these apps is to collect and correlate all this data and make it into some sort of usable feedback. Most probably, your app is the system that's going to receive the data from those cloud services, process it, and display a response to the user. This could be, like in our example, an LED blinking, or it could be something a little more creative, like spinning a rotor. Now, our video series is going to basically walk through a sample that will connect an LED to the Raspberry Pi and control it via GPIO. A few more words, let's break it all down. Now, an LED, or a light-emitting diode, which looks something like this, basically allows current to flow through in only one direction. Now, an LED has a long part and a short leg. Now, the long leg is called the anode, which is connected to the positive part of the circuit, and the short leg is called the cathode, and it's connected to the negative part of the circuit. It's not really hard to break an LED, but you might think that your circuit is broken if you see that your LED is not lighting up. Now, that's a common mistake, and do not worry about it. All you basically have to do is just flip the LED over and make sure that the current is flowing from the positive to the negative side. Super easy, don't worry about it. Now, let's talk about the next device, resistors. LEDs are very notorious. If connected to a circuit, they will completely pull all the juice out of the source. Now, the Raspberry Pi provides a very small amount of current, but if you were to just plug in an LED to the circuit, it would pull all the power source out of the Raspberry Pi. That's when our good friend, the resistor, comes and helps us out. Now, a resistor is this tiny device which basically acts like a security guard in your circuit. The resistor, as the name suggests, is made of a resistive material that prevents the flow of electricity. A resistor's value is denoted by the unit ohms. The higher the ohm value, the higher the resistance. The best part about a resistor is it's bidirectional, so it allows current to flow both ways. So it doesn't matter in which order you connect it. The lines of colors on the resistor denote basically what the resistance power is. Now let's talk about the main component of all of these videos, the Raspberry Pi itself. The Raspberry Pi, as you can see, is a tiny little device over here. It's really, really powerful. It's a small little computer of its own. Looking at this little diagram of what the Raspberry Pi consists of, it has Ethernet ports, as we mentioned before, for connectivity, USB ports, an audio jack. It has a camera module. It has HDMI ports to drive a display unit, a micro USB port which provides it power. A micro SD card, which is the reader underneath over here, is basically where we can host a fully distributed Linux feature if needed. it's more than just like a tiny computer. It's a really, really powerful prototyping tool. The way we interact with different sensors and devices in the IoT in the Raspberry Pi is through the GPIO sensors in the top edge over here. Now, what is this GPIO that I'm talking about? GPIO, or a general purpose input-output pin, are bidirectional pins. This is the pins that you will use to drive all your different electrical components. It could be your LEDs, or it could be your devices, or your sensors. These pins in the top edge of the IoT device over here can be isolated via your code, and then you can use these code to turn LEDs off and on or derive data from your sensors. To do the actual connections of the circuits, we are going to be using a really cool little device. This is called a breadboard. This is what we'll be using to prototype our circuits. Breadboards are called solderless breadboards because the idea is you don't need to actually solder in components and wires together to just prototype or test your circuits out. If you look at this diagram of a breadboard, you can see that the rows, all of the holes at the top of rows over here are connected to each other, and the rows in the middle are horizontally connected to each other. So when you plug in a wire in two holes next to each other, it's as though you've actually made an electronic circuit and they're all connected to each other. So that's less soldering, more prototyping, all your fingers are safe. So in this video, we learned what exactly IoT means, the different words that we'll come across when using this terminology, and we also learned about the different parts that we'll be using in our circuit. Join us in our next video where we'll learn how to put the actual circuit together for our sample.